Unit 9? Where'd Unit 8 go? Yeah, you just finished Unit 7. There's no Unit 8, and we're moving to Unit 9. And it's because there were two Unit 4s, so I got to fix things. Um, so I'm leaving space, and we're going to Unit 9, factoring. And we're going to start with 9.1, which is all about something called GCF, which I'm guessing most of you know what that stands for. But hold off on that. Let's recall problems like this. This was way, way long time ago when we did these types of problems. Maybe even Unit 2? I can't even remember. Um, and hopefully you're looking at these two problems and you're recognizing that they are multiplication problems. Multiplication of polynomials. And all that really is a lot of distributive property. So we would have to do 2x times x squared, so 2 out front, and x cubed. Side note, what's x times x? X squared, not 2x. Some of you guys were still messing that up on one of those last review problems on a test. 2x times negative 4x is negative 8x squared. Remember what you're doing. Here's x to the first, x to the first. You're adding those exponents. And then 2x times 8 would give you 16x. So this is simplified. This is the simplified answer of this multiplication problem. Same type of thing on that second one. You just have a little bit of a different distribution pattern. The first thing to distribute is 6p. That goes here to negative 4p, which is negative 24p squared. And then 6p to 3 is 18p. Then you've got to distribute the 7. So 7 times negative 4 is negative 28p. And then 7 times 3 is 21. Well, we have some like terms here in the middle. So negative 24p squared minus 10p when you combine 18 minus 28, and then plus 21. Okay, so what we were doing was we were simplifying, right? Well, factoring, what we're going to be working on in this section, write down this definition, it reverses the multiplication process. So what we just did was multiplication. What factoring is going to do is reverse that. We don't want to say opposite because the opposite of multiplication is division. Factoring is similar to division, but a little different. So what we are going to end up doing is we're going to have a problem like this red line, and we're going to have to go backwards and get that. Going that direction is called factoring. So we're not trying to simplify the problem. We're actually doing the opposite of that. We're factoring it. So we're going to take something like this last green line, and we're going to have to write it like that. So what you're doing is you're writing this big polynomial as its factors. And factors are just things that multiply together to give you something else. So it's like a really basic version of it is when you just have, say, a number like 6. You could say the factors of 6 are 2 and 3, right? So this process going from this line to this line, that's factoring. We're not going to do it with numbers, though. We're going to do it with polynomials. Okay? All right, so let's try one. First of all, we need to know greatest common factor. We need to know that what that GCF stands for if you didn't already. And the greatest common factor is just the greatest number that's a factor of all of the numbers given. And I'm going to actually update this. It's the greatest factor that is, not factor, sorry, the greatest expression, the greatest term, maybe term would be the best word, the greatest term that is a factor of all of the terms given. Because it's not always just going to be a number. Sometimes it's going to have a variable in it. So we need to call it a term instead of just a number. Sometimes it'll be a number, sometimes it'll be a variable, sometimes it'll be both of those. Okay, so here's a problem. Factor 12mn squared minus 18m squared n squared. And what we need to figure out is what is the greatest common factor of 12mn squared and 18m squared n squared. The first thing you want to look at is the numbers. So we have 12 and we have 18. What you're trying to figure out is what's the biggest number that you could divide both of those things by. So 12 and 18 are both divisible by what number? And then what's the biggest one you could think of? Well, maybe you thought 2. And 12 and 18 are both divisible by 2. But is that the greatest number they're both divisible by? No, because they're also both divisible by, can you come up with something else? Maybe you're thinking 3. 12 and 18 are both divisible by 3. Is that the biggest number they're both divisible by? No. Hopefully you are seeing that there's a bigger number, and that number is 6. So 12 and 18, their greatest common factor is a 6. But we're not just looking at 12 and 18. We have to look at 12n squared and 18m squared n squared. So now look at your next variable, your m. This one is m to the first power. This one is m to the second power. So what's the biggest m they could both be divided by? Could you divide each of these individually by, say, m to the third? Well, no, I can't divide m to the first by m to the third. That won't work. Could I divide them both by m squared? Yeah, I could divide this one by m squared. How about this one? No, it's only m to the first. So the biggest m you can divide them by is just m to the first. Then the last piece is the n's. Well, they're both n squared, so hopefully that's really obvious that they're both divisible by n squared. Essentially what you're going to do is you hopefully know how to find the GCF of just regular plain old numbers like 12 and 18. If you don't, come talk to me and I can try to catch up with that. For the variables, all you're going to do, if they have the same variable, pick the one with a smaller exponent, m to the first. If they have the same variable, same exponent, then obviously it's just going to be that. So the greatest common factor of these two terms is 6mn squared. That is your GCF right there. So you have to write that down. That is what goes out front of these parentheses. And then what we're going to leave in the parentheses is the leftovers. And the leftovers are what are left over if you divide each of these terms by this term. So 12mn squared divided by 6mn squared. Well, 12 divided by 6 is 2. M divided by m would cancel. N squared divided by n squared would cancel. So all we're left with is 2. So what I just did was 12mn squared divided by 6mn squared. Canceled, canceled, and 12 divided by 6 was 2. Now you've got to do the same thing. Negative 18 divided by 6 is negative 3. M squared divided by m, well, that's just going to be m to the first power, right? And then n squared divided by n squared, that part cancels. So we can move this over here. Not that, but that. And that's your answer. This right here is the factored form of this original problem. And if you look back to this slide, that's what I told you were going to do, right? You were going to have a simplified problem, a polynomial, and you were going to have to make it look like a factored version of that. And that's what we have. How can you check these answers? How can you check them? To check your answer, multiply it out. They're the reverse of one another, so just multiply it out. That's all you need to do. Keep in mind, though, be very obvious. That is your answer. So I don't want to see your check written right underneath that, or I'm going to assume that's your answer. So maybe do it as scratch work off to the side, or even in your head, whatever. So 6mn squared times 2 is 12mn squared. 6 times negative 3 is negative 18. M times m is m squared, and there's my n squared. Okay, so you can check these just through multiplication. Awesome, right? All right, next problem. Okay, the first thing you want to do is find the GCF in all the terms. Start with the numbers, 20, 15, and negative 5. Is there a number that you could divide all three of those numbers by? Absolutely. Hopefully you're seeing that it is 5. Then you want to look for common variables. Okay, this one has an a. Do they all have a's? Sure, they do. They all have an a to the what? In other words, they could all be divided by a to what power? Well, this one only has an a to the first, so that's got to be the least one, a to the first. Do they all have a b? Nope, so you can't divide a b out because they don't all have one. Can you divide a c out? Yes, they all have a c to the first power, so our GCF for this problem is 5ac. Then remember what we do, parentheses, and we're going to write our leftovers. So 20abc, what is left in 20abc if you take 5ac out? And remember, you're thinking division. So 20abc divided by 5ac is 4b. 20 divided by 5 is 4. Your a's cancel, your c's cancel. The b is all that is left over. Then, plus sign. 15 divided by 5 is 3. A squared divided by a, that's going to be 1a left over. And c divided by c would be canceled. Okay? Minus 5ac, but I'm factoring all of 5ac out. So what do I write here? A lot of students would tell me, don't write anything, you're done. But let's check that answer. If I were to multiply this back out, I would get, scratch work off to the side, 20 ABC plus, now I'm going to distribute here, 15 A squared C. Is that what my original problem was? No, I never got this part right. So you can't just say it's nothing. If the whole thing factors out, remember you're doing division. So negative 5AC divided by 5AC is negative 1. And then when you write that, if you were to continue distributing 5AC times negative 1, you would get your negative 5AC. So that was your check. This is your answer. Hopefully that makes sense to you. All right. Okay, let's do it again. GCF in all three terms. Look at your numbers first. 3, 12, and 15. What can they all be divided by? What's the biggest number they can all be divided by? 3. Then look at your variables. The only variable we have going on is x. Do we pick x to the third, x to the second, or x to the first? What can you divide all of them by? I can't divide them all by x to the third. They don't all have x to the third. I can't divide them all by x squared. They don't all have x to the second. All I can divide them by is x to the first because they all have at least x to the first. They might have more, that's fine, but they can't have less than what you pick. So x to the first, the smallest exponent is what you want to choose. Factor it out. So if I have 3x to the third and I take 3x out, x squared is what's left. If I have negative 12 and I take 3 out, I'm doing division, so that's 4. X squared divided by x, that's x. And 15x divided by 3x is 5. Okay, how do you check it? You multiply it back out. 3x to the third minus 12x squared plus 15x. Sure enough, that's what I had here. Okay, so remember, going in this direction, that's called factoring. In Unit 2 or wherever we first learned it, we went in this direction, and that's called simplifying. So two very different things, and yes, I will throw both things at you mixed together. You need to understand which one you're doing. Just like when we did that multiplication, we also had addition and subtraction mixed in. You've got to keep it separate. You've got to pay attention to what your problem's asking you to do. Sometimes they don't have 3 terms, sometimes they could have 2, sometimes they could have 12. It doesn't matter. Whatever you have, look for the GCF. The GCF here is 3 with no variables, so this time it's just a number, and that's allowed. If I take 3 out, I'm left with t squared minus 6. I can't go any further. I took my GCF out, I'm done. That's my answer. All right, I'm going to have you guys do these 2 problems. So pause the video now, and you guys do these 2. Okay, check your answer on the first one. GCF was 5a squared, and then your leftovers are 5a squared plus 3. Okay, on this second one, I have some right answer, a right answer, and some wrong answers. Check out what you have compared to what I have. Maybe you got something different. I don't know, but one of these is the right answer. One of these is, two of these are not. This one right here is not the right answer. 3 is a common factor, and I did pull it out, and I pulled it out correctly. But 3 is not the greatest common factor. If I look inside here, these both have x's, and 6 and 4 both are divisible by 2. So unless what's left in your parentheses has no common factors, did I say that right? If what's left in these parentheses have a common factor, you are not done. So if you would have done this, you then would have needed to recognize that there's still a GCF of 2 and x squared. So you could do this in 2 steps. I'd just leave that 3 out front that I already factored out, times, oh, look, there's a 2x that's still in there, squared. So if I factor that out, if I factor 2x squared out of what's in these parentheses, then I have a 3 and a minus 2x left. So 3 times 2x squared is 6x squared, and 3 minus 2x, which is the actual right answer. On this second version, the second wrong answer, I factored out 3x squared. 3x squared is a common factor of those two terms, but it's not the biggest one, because if I look inside my parentheses, both of those terms are divisible by what? 2. They have a common factor of 2. So I would just take a second step. I would keep working. I would multiply it by the GCF that's left still, which is a 2. Pull it out, I have 3 minus 2x. Well, 3x squared times 2 is 6x squared, and then 3 minus 2x is left. Same thing I got. So here's 3 different ways that I got to the same answer. The trick is you have to make sure when you get to what you think is your answer, check in your parentheses. Do your parentheses have a common factor? If they do, you're not done. You have to take another step and find that next common factor. The shortcut, the easiest thing to do is find the common factor right from the beginning. If you do that, then it's one step and you're done. Okay, last one, I want you guys to try it. It's harder. I gave you bigger numbers, more variables and things going on. Pause the video and give it a try. Check your answer against mine. If you didn't get what I got, look in your parentheses. Was there a common factor left? If so, then you needed to take another step and keep going. The best option, though, pick the biggest, the greatest common factor right from the beginning. All right, one word. Oh, wait, before we get to that one word problem, take a look at this one. What's the GCF here? Well, 6 and 7, there's no GCF in 6 and 7. This has an X and a Y, this has an A and a B. They have nothing in common. Remember what GCF stands for, greatest common factor. They have nothing in common. That means we can't factor this. If you can't factor something at all, no way at all, besides maybe factoring, the GCF would be a 1, and that's not going to do anything because you would still have the exact same thing you started with, just stuck a 1 out front. That didn't do anything, so we don't do that. If that's the case, think about it, what a number is called that can't be factored. For example, 7. 7's only factors are 1 and itself, right? What's a number that's like that called? Like 2, 3, 5, 7, 11. What are those numbers called? They are called prime, and so is this polynomial. If you cannot factor a polynomial at all, it is called a prime polynomial, and you're done. Write the word prime, finito, all done. All right, one word problem. A helicopter landing pad or a helipad is sometimes marked with a circle inside a square so that it's visible from the air. What is the area of the shaded region of the helipad below? So we just want to know these blue pieces. Write your answer in factored form. Well, I could find the area of the total square. The area of a square, my side squared. Each side here because it's right side squared, side times side, which would be side squared, is 2x squared. So the area equals 2x squared. That would be 4x squared. That's the area of the square. So I'm just going to draw a little square down here. Then I would need to subtract off the area of the what? The circle. Well, the area of the circle is pi r squared. What's the radius here? It's x. Okay. So if I take the area of the square minus the area of the circle, I would have the area of just the shaded region. The area of the square is 4x squared. The area of the circle is pi x squared. Now that's my answer, but they want it in factored form. So how do I factor this? I got to look for a common factor. What's the greatest common factor these have? Well, this has a 4, this doesn't have any numbers but pi, and this doesn't have a pi. But they both have x squared, so let's factor out x squared. What would be left is 4 minus pi. And this is area, so we're going to write units squared. And there you go. There is your answer. All right, good luck on your packet.